There is another way of algebraically solving systems of equations, and it's got a special name. It's called elimination. This is probably the method that you preferred the most when you were learning Algebra 1. The way elimination works is you would add two equations together. One of the variables would cancel because they'd be opposites, and you'd be left with an equation with only one variable. So in this particular system, the x's cancel. When I add, I get 5y equals 25, so y must equal 5. And remember, that's only half the answer. I got to find the other half. And it doesn't matter which equation you plug back into to find x. So I'll plug into the first one just because the first one doesn't have a negative in front of x. So 4x plus 2 times 5 equals 9. 4x plus 10 equals 9. 4x is equal to negative 1. And x is equal to negative 1/4. So the solution to the system is negative 1/4, 5. But not all systems are that easy. The previous problem, one of the variables was already opposites. What if you have a system like 2x plus 7y equals 4 and 3x plus 5y equals negative 5? When I add these together, I'm not going to be able to eliminate a variable. So I have to set the problem up in order to eliminate a variable. There is this surefire way of setting the system up for elimination that always works. There are easier ways to do it, and if you see the easier ways, we love it. But for those of you who have difficulty with the algebraic part, the easiest way to do this is multiply the first equation by the coefficient in front of the first term of the second equation. So I'm going to put a 3 here. And I'm going to multiply the second equation by the coefficient in front of the first term from the first equation. But one of these needs to be negative, and it doesn't matter which one you pick. I'm going to pick the top one. So I'm going to multiply the first equation by negative 3. I get negative 6x minus 21y equals negative 12. And I'm going to multiply the second equation by 2. I get 6x plus 10y equals negative 10. And now I want you to notice, when I go to add these together, the x's are opposites, so they cancel. Negative 21 plus 10y is negative 11y is equal to negative 22. So y is positive 2. And that's half my answer. Now I need to find out what x is. And it doesn't matter what equation I plug into. I can plug into one of these. I can plug into one of these. I'll pick the first equation just because. 2x plus 7 times 2 equals 4. So 2x plus 14 equals 4. 2x is going to equal negative 10. So x is equal to negative 5. So the solution to the system is negative 5, 2. Well, we learned back in section 3.1 when we solved systems using graphing that there were 3 things that could happen. We could graph 2 lines and the 2 lines intersect, in which case there was one solution. But if the lines were parallel, they would have no solution. And if the lines were the same equation, we said they had infinitely many solutions. How would I know algebraically that that's what's happening? Well, let's address that here in problem 5. What are the solutions of the following systems? So let's look at the system in A. First of all, I want you to notice that the x's are already opposites. So when I add them together, they cancel. Wait a second, the y's are opposites too, and they cancel. When everything cancels, you're left with 0. Equals, oh, wait a second, negative 5 plus 5 is also 0. 0 equals 0, which is a true statement. Oops, don't want to write S. Means that the solution must be that these 2 equations are the same line. And if they're the same line, then it's your infinitely many solutions. So if you have two equations that you go to solve algebraically, and everything cancels such that you're left with 0 equals 0, the solution must be infinitely many solutions because they're the same equation. But what happens here in B? In B, the x's, they're opposites, they cancel. The y's, they're opposites, they cancel. But on the right-hand side, 6 plus 10 does not cancel. You get 16. Well, that's a false statement. Well, if you get a false statement, that means that these two lines must be parallel, in which case they have no solution. So this is how algebraically you can show if there are infinitely many solutions or no solutions.